Algebra 2, Chapter 8, Section 2, Composing and Decomposing Functions. Sometimes it's helpful to decompose a function into simpler functions. For instance, if we have a function x plus 1 squared, we might want to split this into two functions, the act of adding 1 and the act of squaring. That may be helpful for some reason. Also, it may be helpful to compose two simpler functions back into a single function. We write a composition of functions as a function inside a function. And the inner function happens first, and then the outer function. So g of x is the inner or inside function, and f is the outside. So for my example here, g of x, the inside function, would be x plus 1, and the outer function would be f of x is x squared. And f of g of x would be f of x plus 1, which is f x plus 1 squared. X plus 1 squared. So let's do some practice here. If f of x is 5x plus 1 and g of x is x squared minus 4, find the following evaluations. A, f of 2. Well, this is simply putting in 2 for x, and we get 11. B, f of a, put in a for x, and f, we get 5a plus 1. That's all we can do with that. C, find f of a minus 2. Remember, we always put parentheses around where we substitute into the rule in order to get the correct order of operations. So we have 5a minus 5 times minus 2, minus 5 times 2, which is minus 10, plus 1, which equals 5a minus 9. D, we have f of x plus 3, so putting in x plus 3 where we see x in the rule, and we get 5x plus 15 plus 1, which is equal to 5x plus 16. E, f of g of x. Okay, so we need to put in f. The input to f is the rule for g, x squared minus 4. Now putting this input into the rule for f, we have 5 times x squared minus 4 plus 1, which is 5x squared minus 20 plus 1, which is 5x squared minus 19. And for f, we have g of f of x. F of x's rule is 5x plus 1. Write that here. Put that as the input to g, and we get 5x plus 1 squared minus 4. 5x plus 1 squared is 25x squared plus 5x, 1 times 5x, plus 5x, 5x times 1, plus 1 times 1 is 1, minus 4. Gives us 25x squared plus 10x. 1 minus 4 is negative 3. And that is our composition. Notice that the answer to f and e is not the same. Okay, and that's important. The order matters when we're composing often. After 10 years, the value V in dollars of a $5,000 certificate of deposit earning annual interest X is given by this following function. V is 5,000 times the quantity 1 plus X all to the 10th power. So 10 represents the years, X is the rate, 5,000 is the initial amount we deposit, the value is what we get out. Express the value as a composite of simpler functions and interpret each function in terms of finance. So we could break this down into the inner function 1 plus x. So we could have, we can just call it, I'm going to call it b of x is 1 plus x. So this is converting, this function's in terms of finance is converting the rate we're given into a factor, something we can multiply by. Okay, now we might have c of x mean x to the 10th power. This would be, in terms of finance, the 10 years of interest. Okay, so we earn 10 years of interest. We multiply the factor 10 times by itself. And then we might have v of x be multiply x by 5,000. And this represents applying the interest to the deposit value, or the deposit amount, the initial value. And then we can write v, sorry, maybe I shouldn't use a v here. Let's call this d of x. Then we can write that the value, v of x, is d of c of b of x. And there's no reason why we can't compose twice. So our innermost function is add 1. Our next function, because remember we have to do parentheses, then exponentiation, then multiplication. Our next function is take the 10th power, and our third function is multiply by 5,000. So we've broken our function into three littler functions that represent the three operations that we're doing on our input. And we've written them as a composition, d of c of b of x, where d was applying the principal to the interest, basically, or the deposit to the interest by multiplying by our 5,000. C represented taking our 10 years of interest. B represented converting our interest rate into a factor we can multiply by over and over again. Express each of the following as a composition of two simpler functions. Then express each as a composition of three simpler functions. So A, we could have two functions. F of x could be 2x plus 1. And g of x could be, take the 5th power. Then we can represent this as g, this y, which is an unnamed function. I guess there's no, I'm not using function notation. It's y of x, I suppose. So y is then f, sorry, not f, the outer function is the 5th power, so g of f of x. And now we can break f of x up into some smaller functions. We'll call it a, which could be multiplied by 2, and b, which would be add 1. So then we can break this into, our outer function will be the same g, but basically breaking f up into the outer thing would be adding 1. In this case, we multiply by 2 first. So b of a of x. So if you think about going backwards, a of x is 2x, b of x is add 1 to that, g of that would be take that to the 5th power. If we get a and b backwards, if we add 1 before we multiply by 2, we would get 2 times x plus 1, which is different than 2x plus 1. So the order matters greatly here. B, we can decompose this into f of x would be 1 over x, representing to divide something, basically invert something multiplicatively. G of x could be square root of x squared plus 1. We could write y as, the outer function here is the inversion, f of g of x. We could split it into three functions by splitting g up. We still have a choice of how to split here because there's three operations happening. So let's rewrite this as q of x means take the square root, and p of x means x squared plus 1. And so then we could write this as f, and we can rewrite g as the outer function here is taking the square root. It's the last thing we do. Q, so we're working backwards essentially of p of x. That'll give us back the y. C, y, so here we need to break this into two functions. Let's choose for our outer function f of x to be 2x cubed plus 1, and our inner function g of x to be 5 minus x squared. So here's our inner, and our outer is, think of this as x. See that? So if you replace 5 minus x squared with x, we have the outer. So we can write outer f of g of x. Breaking this up more, we could break up either the outer or inner here, both complicated. Let's break up the outer this time. So if we have c of x, it means do 2x plus 1, and d of x means cube it. Then we can rewrite it as y equals c, because c is the outer thing, d of f, sorry, not f, g, which is the innermost thing, of x. C of d of g. So we have 2x plus 1. Then our x would be x cubed, and then we'd have 5 minus x squared inside the cubed.